Welcome to True Projects. In this video, we are going to explain about the project title Stroke Risk Prediction with Hybrid Deep Transfer Learning Framework. The introduction describes the serious issue of stroke, which is a major cause of mortality and disability worldwide. It highlights the pressing need for precise stroke prediction in order to save lives and cut down on medical expenses, particularly in light of the dearth of label data and privacy issues in the healthcare industry. Traditional deep learning models have trouble managing unbalanced data, and there aren't many datasets available for strokes. The project offers a hybrid deep transfer learning (HDTL) system that combines generative instance transfer with active selection to take advantage of associated medical data in order to address these problems. The system exhibits higher performance in both simulated and actual scenarios of stroke risk prediction and may be implemented in numerous institutions while protecting patient privacy. Using Bayesian optimization, model parameters can be efficiently adjusted. The goal of the project is to develop an effective stroke risk prediction with hybrid deep transfer learning framework through the use of a hybrid deep transfer learning strategy. This program seeks to reduce stroke-related mortality and healthcare expenditures. It incorporates a number of machine learning models including a voting classifier, DNN, CNN plus LSTM, SVM, DT and RF. The project seeks to increase the accuracy of stroke risk prediction by utilizing a variety of data sources and methodologies such as SMART, oversampling and feature selection. Additionally, it provides a user-friendly Flask interface for real-time personal data input, encouraging earlier intervention and more effective stroke preventive measures. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements. In software requirements, we have Anaconda 3 and Visual Studio Community version. Flow of project. To implement this project, we have designed the following modules. The first module is importing the packages. In this initial step, the necessary Python libraries and packages are imported. These libraries provide essential tools and functions for data manipulation, analysis, and machine learning. Exploring the dataset. Stroke data. Here, the project involves loading and examining the stroke dataset. This exploration includes understanding the data structure, its features, data types, and gaining insights into the dataset's characteristics. Visualization using Seaborn and Plotly. Data visualization is crucial for understanding patterns and relationships within the data. Seaborn and Plotly are data visualization libraries that help create informative and visually appealing charts, graphs, and plots to highlight key information in the data. Univariate and bivariate analysis. Univariate analysis focuses on examining individual variables in the dataset, such as calculating summary statistics, visualizing distributions, and identifying outliers. Bivariate analysis, on the other hand, explores relationships between pairs of variables, helping to uncover correlations and dependencies. SMART oversampling. SMOT, synthetic minority oversampling technique, is a technique used for addressing class imbalance in machine learning datasets. In this project, SMART is applied to oversample the minority class, possibly stroke cases, to balance the dataset. This helps improve the model's performance by preventing bias towards the majority class. Data processing. This module involves preparing the dataset for machine learning. It includes tasks such as handling missing values, dealing with outliers, and converting categorical variable into a format suitable for modeling. Hybrid deep learning. Hybrid deep learning refers to a combination of traditional machine learning techniques and deep learning methods. It's a versatile approach that leverages and strengthens to improve model performance. Stacking the values. Stacking involves merging or combining different datasets or data sources. In this context, it could refer to combining features or data from various sources to create a unified dataset for modeling. Converting the stack value into tensor. Tensors are multi-dimensional arrays used in deep learning frameworks like PyTorch and TensorFlow. Converting data into tensors is necessary to feed it into neural networks for training. Stacking the continuous columns and converting to tensor. This step specifically involves stacking and converting continuous numerical features into tensors. It ensures that numerical data is in suitable format for deep learning models. Converting target variable to tensor and flattening since cross entropy loss expects a 1D tensor. The target variable, which represents the outcome to be predicted, that is stroke or no stroke, is converted into a tensor. Flattening the tensor means converting it into a one-dimensional array, which is often required when using certain loss functions like cross entropy loss. Deep neural network and CNN plus LSTM. These are different types of neural network architectures used for modeling. A deep neural network (DNN) consists of multiple layers of neurons, while CNN (convolutional neural network) plus LSTM (long-short-term memory) is a combination suitable for processing sequential and image data. Data normalizing. Data normalization is the process of scaling data to have a common range, typically between 0 and 1. This ensures that all features contribute equally to the model and helps in improving training convergence. Data transform. Data transformation encompasses various pre-processing techniques like feature scaling, encoding, and dimensionality reduction to improve the quality of data for modeling. Machine learning. This likely refers to the application of various machine learning algorithms such as support vector machine (SVM), decision tree (DT), random forest (RF), and voting classifier to predict stroke risk based on the processed and transformed data. Label encoding. Label encoding is a technique used to convert categorical data into numerical format, making it suitable for machine learning models. Feature selection and splitting the data into train and test. This module involves selecting the most relevant features or variables from the dataset to use for modeling. Feature selection helps improve model performance and reduce overfitting. Afterward, the data is divided into two subsets, one for training the models and the other for testing and evaluating the performance. Building the model. This is the core of the project where different machine learning and deep learning models are constructed and trained to predict stroke risk based on the selected features. Hybrid Deep TL. Hybrid deep transfer learning combines the power of deep learning with transfer learning techniques. Transfer learning involves using pre-trained models and fine-tuning them for a specific task, which can be particularly useful when working with limited data. DNN, Deep Neural Network. DNN is a neural network architecture with multiple hidden layers. It's suitable for complex tasks and can capture intricate patterns in data. CNN plus LSTM, convolutional neural network plus long short-term memory. This hybrid architecture combines CNN, which excels at processing image-like data, with LSTM, which is effective for sequential data. It's useful when dealing with datasets that contain both images and time series information. SVM, Support Vector Machine. SVM is a machine learning algorithm that is effective for both classification and regression tasks. It works by finding the hyperplane that best separates data points of different classes. DT, Decision Tree. Decision trees are simple yet powerful machine learning technique that build a tree-like model to make decisions based on feature values. RF, Random Forest. Random Forest is an ensemble learning method that combines multiple decision trees to improve prediction accuracy and reduce overfitting. Voting Classifier. The voting classifier combines the predictions of multiple models, that is SVM, DT, RF, to make a final prediction. It can be set up as either a majority vote or a weighted vote depending on the model's confidence in its predictions. Training the model. In this phase, the selected machine learning and deep learning models are trained using the training dataset. The models learn from the data, adjusting the internal parameters to make accurate predictions based on the provided feature. Building the model with voting classifiers, since it gives better score and less MSE comparing with other models. After training, the project selects the voting classifier as the primary model for making predictions. The voting classifier combines the outputs of multiple models, that is SVM, DT, decision tree, RF, random forest, to enhance prediction accuracy and reduce mean square error MSE compared to individual models. Flask framework with SQLite for sign up and sign in. The project employs the Flask web framework to create a user interface for sign-up and sign-in functionality. SQLite, a lightweight relational database, is used for storing user account information securely. Users gives input as feature values. Users provide the personal and health related feature values which are relevant for accessing stroke risk. These inputs are collected via the web interface created using Flask framework. The given input is pre-processed for prediction. The user provided feature values undergo the same pre-processing steps as the training data. This ensures that the user's input is in the correct format and can be fed into the model for prediction. Trained model is used for prediction. The pre-processed user input is then passed through the trained voting classifier model, which combines the predictions from the multiple models. The model calculates the likelihood of stroke risk based on the user's input. Final outcome is displayed through front end. The project's front end, built with Flask, displays the prediction outcome to the user. It provides information on their estimated stroke risk, helping them make informed health decisions. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, etc. which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file, which contain algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and then paste the copied path and hit enter. This command is used to change the correct directory to the code folder's path. Compile the app.py file using the command python space app.py. I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, that is 127.0.01 and port, that is 5000. Now copy this local link and paste this in the web browser. I usually prefer Google Chrome. And hit enter. The home page of the project is displayed in the browser. So this is the home page. This is the front end built using Flask framework. Now click on sign up. If we are a new user, first we need to register. But I have already registered, so click on sign in. So this is the login form. Enter the username and the password. And click on login. This is the home page of the project. So here, these are the parameters which we need to fill. After filling these parameters, we will predict whether the person is suffering with stroke or without stroke. Now let us fill all these details. Gender, male, age, 67, hypertension, false, heart disease, yes, Ever married? Yes. Work type? Private. Residence type? Urban. Glucose level 228.69. Body mass index 36.6. Smoking status? Formerly smoked. So here I have entered all the required details, gender, age, etc. Now click on submit to predict whether the person is suffering with stroke or without stroke. So here this is the outcome. Based on the input, the patient is predicted with stroke. So here we can see that this person is suffering with stroke. Now let us enter another patient's detail. Choose the gender, female, age 47, hypertension, pulse, heart disease, no, ever married, yes, work type, private, residence type, urban, glucose level 210.95, body mass index 50.01, smoking status unknown. Now click on submit. Heart disease, no. So here this is the outcome. Based on the input, the patient is predicted with no stroke. So here this person is having no stroke. Now let us enter other patient details and find whether the person is suffering with stroke or without stroke. Male. So here I have entered all the details. Gender, male, age is 58, hypertension, true, that is the person is having the hypertension. Heart disease, no, that means the person is not having the heart disease. Ever married, yes. Work type is private, residence type is urban, glucose level is 87.96, body mass index is 39.2, and the smoking status is never smoked. So here the person has never smoked and the person is not even having the heart disease. So now click on submit. So this is the outcome. Based on the input, the patient is predicted with no stroke. So here we can see that this person is not suffering with the stroke. Now click on sign out. The conclusion of the project is: the project involves pre-processing several machine learning models and data exploration. Following extensive investigation and model training, the voting classifier emerges as the best successful stroke risk predictor. Utilizing both conventional and deep learning techniques, this strategy provides a reliable and convenient solution for assessing the risk of having a stroke. It makes precise forecasts possible, strengthening medical decision making and perhaps enhancing patient outcomes. It is a useful tool for healthcare professionals and anyone looking to understand the stroke risk because it is integrated with a Flash-based user interface, which makes user interaction simpler.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.